Up till now, we have done so many things for this project, and this is kind of a full-fledged project at this moment. First of all, we saw how to clean the data. After cleaning the data, we did some analysis onto that data. We did spatial analysis, some of the analysis that is related to business model, and so on. So we did so many analysis. After that, we perform something that is called as selecting the important features using some techniques, and we distinguish between the numerical feature and categorical features. Then after, we did something called as a feature encoding, where we encode the categorical variables using mean encoding technique. Then after, we prepare our data. Then after, we prepare our data and we divide it into the two numerical and categorical features. We handle the outliers, and similarly, we also did something called as a feature importance. Now this is a full-fledged project. This is a life cycle of data science project. Now finally, it is a time which is to split the data and build the model. So splitting the data, it should be splitting the data and model building, or building the model. So this is the last step, and then this will be your full-fledged project which you can use to build the profile for your career as a data scientist. Now let us split our data. So if you remember, what was our data? Our data contains X and Y. So the X contains all the independent variable. So this is for independent variables, and Y is our dependent variable. And now, in order to build the model, we need to split the data into training and testing set. So for that, I'm going to use scikit-learn, and we have this inside the scikit-learn model selection. So from this model selection, I'm going to import train test split function. And now using this function, I'm going to split my data. So I'll call train test split function, and I need to pass X. What is X? It is a independent variable. Y is a dependent variable, and let us give the training size. You can also give the test size if you want. Now I want the training size to be 0.75, which means 75% of the data will be used for training, and the remaining 25% will be used for testing. Now I want random state so that my train test split will be reproducible. So I'll just give some random number. Now after we split it, I'm going to get 4 variables. First will be X train. Let me just create a variable for it. So I will give training for X and testing for X. Y will be also training of Y and testing of Y. So test, let's say test. So we are going to split into X and Y into the training and testing set. Now if I run this module or run this chunk of a code, then 4 variables will be created, and let us use these 4 variables in order to train and test our model. Now first of all, after splitting the data, the next step is to build the model. Now in order to build the model, we need some algorithm, some machine learning algorithm. In the scenario of our example, what are we going to predict? That is the important thing. We have this many independent variable that is highlighted in this yellow color, and we have this which is dependent variable which our machine learning model should predict. Now, is cancelled is the attribute that our machine learning model should predict. Now, what are the values inside these is cancelled attributes? It is either 0 or 1. So that means there are two categories, either 0 or 1. So that means it is a classification problem because we are classifying the data either in the 0 class or 1 class. So that means this problem can be expressed as a classification problem. So in the case of classification problem, we have multiple algorithms. Like we can use logistic regression in the case of binomial or binary, that is classes. So here it is a binary classification because the classes we need to predict is either 0 or 1. So that means we can use logistic regression also. We can use naive Bayes algorithm, or we can also use decision tree and so on. So we can use the classification algorithm to solve this problem. So let us go here and let us start with a simple logistic regression, and we are going to test on the further model also. First of all, I'm going to start with logistic regression. Maybe I can also just give here a markdown saying I'm going to implement logistic regression. So we cannot use linear regression in the case of classification problem, and we have already discussed about it. So let us import all the libraries that we need in order to implement the logistic regression. So from the linear model, I will import logistic regression. So this is just an import statement. So I have just imported the logistic regression. Let us go down and use this logistic regression on our training data sets. So I'll just go down and I'll just say this is the model, or maybe I'll just say logistic model. So this is the logistic model, and I'm going to just create an instance of logistic regression. And we might have different properties if you want to give inside the logistic regression, but for now we'll stick with the basic ones. Just the default attributes or the argument will be used in our model. So now we need to fit the logistic regression to our training set. So my logistic model is logistic model dot fit. So whenever I will call the fit function, then training will happen, and I'm going to pass here x train and y train. So basically x train that we have splitted and y train will be passed to this fit, and this is nothing but a training of the model, and in our case the model is logistic regression. So I can just run this now. It will take some time because we have huge chunk of data. So now logistic regression model is fitted. Now next thing what we can do is we can use this model to predict. So I'll just say logistic model is the model that we have just created, and I can call the predict function to use this model in order to do prediction on our testing data. And what is the testing data? X test is our testing data. Now if I run this, then you can see we will have these many, that is our test that has been done by the model, and now this test and the actual value of the y will be compared. Now this is a classification problem, and if you remember, if you want to evaluate your model in the case of classification problem, or if the problem is classification and you just fitted your model, then the confusion matrix can be used in the case of classification problem in order to evaluate your model. And if the problem is regression, like let's say if you use some linear regression model, then the matrix that will be used to evaluate a model will be RMSE and MSE, which is root mean square error. So that will be used for regression tasks, and for the classification tasks we normally use confusion matrix. Now in order to evaluate how good or bad our model has done on this testing data, we need to check on the confusion matrix. So in order to use the confusion matrix, I'm going to use the scikit-learn, and I'll call this matrix function. From this I will just import confusion matrix. I'll just run it. Now confusion matrix has been imported. Now let us use this confusion matrix, and in this confusion matrix you need to give the actual data, which is the actual data. Here is the actual data, the actual y, and now we need to give the model predicted data. So here is what model has predicted. So this is the prediction by model. Now whenever the model will predict, I will put it inside ypred variable. Inside the ypred variable I will store the values that has been predicted by our logistic model. Now the confusion matrix should be plotted against the actual and predicted. And what is the model prediction? It is ypred. So I'll just put here ypred. Now if I run it, then you can see this is our confusion matrix. Now in order to find, that is, the accuracy of our model, we will go down, and I'll just import another matrix, and that will be accuracy score. It is so easy to use the library accuracy score. If I run this, then accuracy score has been imported. Now let us use it to find the score. So accuracy score, and let us pass the y-test and ypred that has been done by our logistic model. Then you can see our logistic model has accuracy of 76%. Now this is what the model building or implementation of model looks like. Now let us play with multiple algorithm. Let us implement multiple algorithm now. For example, we can have naive Bayes algorithm. Maybe we can also have k-neighbors classifier, or we can also use decision tree classifier, and so on. So let us use those one by one. So here I'll just go down, and I will create a new cell right here, and I'm going to give the markdown saying we are implementing different classification algorithm, and we will check which works best for us and which will have the highest accuracy. We will use that for our implementation or deployment. So here we can use multiple algorithms. Maybe we can use something called as logistic regression. We already use right here at the top. So for the classification we use logistic regression. Maybe we can also use naive Bayes algorithm. We can also use random forest algorithm. This looks promising, random forest. Maybe random forest or KNN might have the highest accuracy. And next we can also use decision tree, and also we can use something called as k nearest neighbor algorithm. So these algorithms can be used for any classification algorithm. So let us give, that is, I want to write it in the small heading. Now let us run it. Now we can implement all of these algorithms right here. So I'll go down, and now I can just import all of these algorithms first of all, because if you want to use them, either you can write your own function or classes to do it, or you can also use the scikit-learn library. We will have a different course in order to implement them from scratch, but for now we will be using just a library. So naive Bayes. So first is a naive Bayes that I have imported. Next I can import something called as neighbor. So from neighbors I will import k nearest neighbor. So I have this neighbors classifier, and we can also have the ensemble in order to have the random forest classifier. So ensemble technique basically means you are creating a different decision tree, and that is called a forest. And in the case of forest we are using random forest here. And we can also have another algorithm, that is tree, which is nothing but decision tree classifier. Decision tree classifier. So we can use all of these algorithm and check the accuracy of each of them and compare with that is logistic regression also, where we have created at the top, and we will use the one that has the highest accuracy. Now run this line of a code, then it will be executed. Now next, what I want is, I want the models which will be empty, and I will store all the models that I will create over here, and models dot append, because this is a list I can use append method. First let's say I want logistic, maybe logistic regression is already created, maybe let's start with naive Bayes. So first one is a naive Bayes, and just create an object of Gaussian naive Bayes which we have imported right here. So this is for the naive Bayes. So the first model will be for the naive Bayes. I can in fact copy it for all the algorithms. We have 4 algorithms. So second instance will be for, let's say, maybe I can use Gaussian. Gaussian is already made. Random forest classifier, which is right here. So I'll just copy it and I'll paste it right here. So random forest classifier is the next one. I can copy decision tree right here and I'll just paste it. And the next one is k nearest neighbor. I'll copy it and I'll paste it right here, k nearest neighbor. Now in the case of k nearest classifier, we need to pass some arguments to it, saying n neighbors should be 5. This is the value of k. So I want to check 5 neighbors for each of these testing data sets. Now if I run it, I got an error saying Gaussian, it is naive Bayes. I'll copy it. It is Gaussian naive Bayes with a capital NB. Now let us run it. All the models has been built now. Now I can just run all of these models at once. So if we have multiple things to do, you must know by now what we can use. Obviously we can use for loop. For name and the model, in models, name in the model in models, in this model attributes, I'm going to print the name of the model. This is the name of a model like naive Bayes. Okay, I need to just change this. Second one is not the naive Bayes. The second one is random forest. The third one is decision tree, and the fourth one is k nearest neighbor. I'll just type knn. Now after I print all of these names, so name here means naive Bayes, random forest, decision tree, and knn is the name, and the model is this model. This is the model. After printing the name, I can fit this model one by one. So I'll just call the fit function all at once and train, and the test data will be given. It should be ytrain. So training data will be given in the fit model. So fit is called whenever you want to perform a training of the model. Now making of predictions. So here I will make predictions using this model that we just import. So basically I'm using for loop. So first of all, naive Bayes will be fitted and the prediction of the naive Bayes will be done, and at second iteration random forest will be fitted, and the prediction will be done at third iteration decision tree, and at last KNN will be done. Now whenever prediction will be made, I'll just store it in the predictions. I'll call the model and I'll just call predict function to it, and I'm going to give x test to it in order to predict for the testing data. Now next is to compute the error. Let us also compute the error. So error here, or evaluate, maybe I can also say evaluate a model. Evaluate a model. So in order to evaluate a model, I am going to just import scikit-learn matrix, import confusion matrix, and I'll just print this confusion matrix for each of the model. I'll pass here predictions and the actual values of y. So this is a prediction that will be done by each of these model, and y test is the actual y. So now after the confusion matrix is made, next is I want to get the accuracy of each of these models also. So from scikit-learn.matrix, I want accuracy is score matrix, and I'll just print accuracy is score by giving the predictions and y test to it. So this way I will just print the score, and maybe I'll just give some space, some tab maybe, so that after each of the iterations I'll get to the new line, maybe new tab or new line. I'll just give new line. So now this is all we will have in order to fit all of these models. So first of all, naive Bayes will be taken, it will be fitted on this model, it will make some prediction, confusion matrix will be plotted, and accuracy score will be plotted. Then after, again we go to the random forest, we do the same tasks, and again we go to decision tree, and so on. So this way we make a predictions, we make a confusion matrix of all of these algorithm at once, and we check the accuracy also. So let us run this. Now you can see it is running. So first naive Bayes, we got naive Bayes, and I think what I miss over here was that I need to stop it. I didn't run this line, I guess, so I'll just run this line. And now let us go here and let us run this now. So naive Bayes is already trained, and you can see naive Bayes has so little accuracy. Now random forest is working, and it is taking some time. It is still predicting or fitting the model, because our data is so large. If you see, it is quite an observation. We have so many data, so it will take some time for the random forest to work. So let us give some time for it to work, and after random forest we will have decision tree and KNN, and after each of them have processed, you can see the accuracy for the random forest is so high, that is at least 95% of accuracy. That is really good. Now we have the KNN at last, and it is working. So earlier when we implement the logistic regression, we had the accuracy of 76, and naive Bayes was really low to just adapt that accuracy. So naive Bayes had really low accuracy. We have the random forest and the decision tree, which have the proper accuracy about 95%. So random forest is working really good at this moment of a time. Now let us wait for KNN. Maybe KNN will also work in a better way. Let us give some time in order to train the data and test it, and after testing it will give us the accuracy score, and we will find which model did the best for our tasks. Finally, we have a solution for KNN model also, and it gave us 94%. So in fact, decision tree work better than the KNN, and KNN is kind of a lazy algorithm, so it only works on the testing data. While training, it only stores the data, but whenever we test the model, so the distance will be calculated, and all the stuff of KNN algorithm will be done at testing. So it might take a lot of time to model and to fit this model. So just relax until and unless you get the output. Now we can clearly see random forest is having the highest accuracy. So we can use the random forest for the deployment of our model, and based on your requirement you can also either use decision tree or KNN also, because decision tree might be that is faster than the random forest. In our case, KNN took a lot of time, but random forest was faster, and even Naive was faster, but see the accuracy. It is in fact really less than even a logistic regression. So that is all in this video. We saw random forest worked better for our project, and we can use this for our deployment. So that is all for this project. We had done so many things, and this is a complete life cycle for any data science related project. So there will be people who will divide these tasks. You will not be doing these tasks while working in the company by yourself. So whenever you clean the data, there will be data scientist, maybe DB manager, and some database administration people that will be working together with you. And all of these people collaborate together to perform and create a full-fledged working project in the dynamic environment. So that is all in this video. In the next project, we will be checking out NLP, which is the implementation of natural language processing, and we are going to take a step ahead to the part where we can learn how to create a big and fully fledged data science project that is related to processing and planning natural language processing project. So that is all for this project. I'll see you on the next one. Just make sure that you make this full-fledged project, and you can have each and everything on the resource section. You can change some part of the code, you can play around with some part of the code, and make sure that you get good grasp on each of these concepts, because this is the life cycle for the data science project. And if you want to become a good data scientist, then you should get good idea regarding these concepts. And that is all in this video. I'll see you on the next one.